Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to continue in Lesson 8 here on Linear Programming, Part 3, the applications of systems of inequalities. And we're going to go over Example 2 today. So let's scroll down in our notes here and go to Example 2. We did number 1 yesterday, and now we're in number 2. So number 2, what is it all about? Let's read the problem and dissect it into pieces and fill in the table and go through the linear programming steps. So in this problem here, this accounting problem, an accountant prepares tax returns for individuals and small businesses. So we have type number 1 here, type number 2 here. I can already tell there's 2 types of tax returns. All right, one's for individuals and one's for small businesses. On average, each return, individual return, requires 3 hours of her time. Oh, I guess the accountant is a her, it's female. Okay, so we know already that the individual return, I'm talking about individual return here. All right, remember there are 2 types, individual and then there's the business tax return. And we're describing what's going on with each. So on the individual return, it requires 3 hours of her time. So 3 hours of her time and 1 hour of computer time. So 3 hours of her time, 3 hours here, and 1 hour of computer time. This is in hours. Okay? Now, not true for the business tax return. They're bigger, more complicated, it takes more time. So on the business return here, 4 hours of her time. It's a longer return, guys. It's for a business, more complicated. So 4 hours of her time and 2 hours of computer time. Because of other considerations, her time is limited. Okay, this is an important word right here, limited to 240 hours. That means that this number right here is a maximum. All right, so let's circle that. It's a max. That means that the time available for her time now is less than or equal to 240 hours because this is a max time. Less than or equal to 240 hours because it's a max number, a maximum. Whenever you have maximums, you got to be less than or equal to that value. And the computer time is limited to 100 hours. Again, notice the key word right here, limited. Computer time is limited to 100 hours. So I already know that whatever we do here, the time for individuals plus the time for business tax returns has got to be less than or equal to 100 hours. Okay, because of the keyword limited right here. We're talking about maximums. Either that number or less. Okay, that's why we see the inequalities right here. Now the profits on each are different too. Profits right here, $80 on an individual and $150 on a business. So $80 profit for an individual and $150 for a business return because they're bigger, they take longer, and require more time on her part and more computer time. So they're going to be worth more. Okay, you're going to get more profit here, so remember that. That's going to give us our objective function. Now we don't know how many returns of each type that we should make, or that she doesn't know. And it's our job as a mathematician, through some linear programming steps here, to determine how many individual tax returns and how many business tax returns she should prepare to maximize her profit. So this right here, this part, actually let me redo that. This part right here is the key of the problem. How many? How many returns? Well, let's let x equal to the number of individual returns and y equal the number of business tax returns because we don't know how many she needs to prepare to maximize her profit. This is the goal or the objective to the problem. Let me highlight that. That's the goal, the objective. Okay. So we know we need to maximize the profit through, preparing individual and business tax returns. We just don't know how many. So let's define our variables. Okay, so this right here gets down here. We don't know how many individuals we should prepare, or that she should prepare. So number of individual, all right, tax returns. Y is equal to the number of business tax returns. Again, we're the mathematician. It's our job to figure out how many of each to maximize our profit. All right, that's the whole goal of the problem. So what we want to do is this. We're going to have a constraint on accountant time and constraint on computer time. So let's write that down. An accountant time, all right, and then we're going to have one on computer time as well, because there's maximum time available here. Well, we know that there's 3 hours for every individual tax return. So for one tax return, it's 3 hours. For 2, it's 6 hours. Just double that. For 3, it's 3 times that, or 9 hours. For 4, it's 4 times that, or 12 hours. But in general, we got to take the time it takes for each return and multiply by how many, which in this case is x. So I got 3x hours, all right, for the individual return on her time, and then 4 times y hours for her time there, because we got time for the individual. It takes time for her to do the business tax returns. 4 hours for each return here, multiplied by how many, y, so plus 4y. That's got to be less than or equal to 240 hours, because she only has so much time in the day to do this. All right. Now it takes some computer time too. So for every tax return, it takes 1 hour. For 2 returns, 2 hours. 3 returns, 3 hours. But in general, it's 1 hour for every return. So we want to multiply 1 hour times how many we have, x. So 1x plus, and the business returns, it takes 2 hours of computer time for every return. So for 2 business returns, it's 2 times 2 or 4 hours. For 3 returns, 6 hours. 4 returns, 8 hours. But in general, it's 2 times y. So 2 times y hours for the business returns. So we got the time here for the accountant time, computer time, and for the individual return, plus the time it takes for the business returns on the computer. It's got to be less than or equal to 100 hours total. Now, these variables can't be negative because you can't have a negative tax return. So your non-negative constraints make sure that they're both positive. So x greater than or equals 0, y greater than or equals 0. And you're ready to almost begin the problem. But you got to take the profit function and write the goal. Remember, this objective means goal, or goal function, objective function. You know, in linear programming or any LP problem, it's called the objective function, which basically is your goal. Okay. Now we know that for every individual tax return, we get a profit of $80. So for one return, we get $80. For 2 returns, 2 times 80 is 160. For 3 returns, it's 3 times 80 or 240. But in general, you multiply here, and so the profit function, all right, P for profit, is going to be $80 times how many returns you prepare, plus, all right, $150 for every business return. So we got to add 150 times y, because y represents the number of business returns. And that gives us our profit function. Now our goal is to maximize it. So what we need to do as mathematicians, let's write down maximize here, is graph these inequalities, find the corner points, and use those corner points to maximize all these conditions or limitations or what are called constraints in the problem. Okay, so I'm going to call this inequality 1, this one number 2, and we got the non-negatives here. So let's take the one up here. We got 3x plus 4y less than or equal to 240. All right, we want to subtract 3x, and you get 4y is less than or equal to negative 3x plus 240. Let me write it better. There you go. Divide everything through by 4. All right, and I have y less than or equal to negative 3/4 x plus 60. 240 divided by 4 is 60. Okay, so then inequality number 2, we got x plus 2y is less than or equal to 100. Subtract x. 2y is less than or equal to negative x plus 100. Divide everything through by 2. And be careful here, y is less than or equal to negative 1/2 x plus 50. So I have this one and I have this one so far. And notice the y-intercepts here. This slope, y-intercept, slope, y-intercept. Look at the y-intercepts. They're 50 and 60, which means I've got to change my scale. So I'm going to do that. I'm going to change it. I'm going to count by tens. So 10 here, 10, 20. Actually, I'm going to count by fives. So no, I'm going to count by 10. So I'm going to do that. So 0, this is 10, 20, 30, 40, 50, 60. Same thing here. Okay, so it's 0, 10, 20, 40, 50, 60, 70, 80. Okay, so I changed the scale, count by 10. So I got to change the scale so I can graph these functions. Okay, now what I want to do is start graphing, and I'm going to start plotting the first inequality here at 60. Now check this out. I got a slope of negative 3/4. Now a slope of negative 3/4. I'm going to bring it down here. The slope of negative 3/4 is the same thing as negative 30 over 40. All right, multiply both those by 10. So I got to go down 30, right 40. Down 30, right 40, because I'm counting by tens. Down 30, right 40. Down 30, right 40. Plot your points. All right, so get your straight edge out, graph your line, be accurate. It's less than or equal to, so below. That's inequality number 1. Number 2, got a slope of 50, so I'm going to switch to red, now blue. Slope of 50 here, no, I'm going to go red, so it pops out. There we go. And negative 1/2, so a slope of negative 1/2. Negative 1/2 is the same thing as negative 10 over 20. So I go down 10, right 20. So down 10, right 20. Down right 10, right 20. Same thing. All right, and then graph from there. Okay, it's less than or equal to, so shade down. Solutions are below. That's inequality number 2. Okay, I can already tell there's a corner point right here. They intersect right there. And now my third inequality right here, x greater than or equal to 0, as you guys already know because we've been doing it for the last 2 weeks, is a vertical boundary line, x greater than or equal to 0, vertical. All right, next one, last one, this one, y greater than or equal to horizontal, and it's going up. All right, y greater than or equal to 0. Okay, so they intersect all in through here. All the inequalities overlap where all the colors meet and become one. Okay, so this is my feasible region right here. It's my solution region. Feasible region, solution region. I've got 3 corner points. I've got this one A here. Let's write down the vertices up here. I've got A, I got B, and I've got this one C. So B and C, and this one D, I guess we can consider it's the origin. Not going to be very useful though, because that means you don't build anything or you don't do anything, right? And we're accountants, we're in for making money here, so we're obviously not going to be doing that. 0, 0 means 0 individual returns and 0 business returns. That means we don't do anything, we sit on our butts. And that's not going to work, all right, because we want to make some money. So what is A? Okay, A is 50 units up, so 0, 50. B, 40, 30. C is 80, 0. D is the origin. Okay, so there are the vertices. And what we need to do now is remember the programming theorem that states that the optimal solution occurs at one of the corner points. Okay, whether you're minimizing or maximizing, the corner points always represent one of the possible solutions to optimize the problem. All right, you can check any point in here. Any point in the yellow area will satisfy all the inequalities, but they won't maximize their objective function. Only the corner points will. So we've got to take our corner points over here, and we've got to work with them. A, B, C here, C is 80 comma 0, and D, this is really a non-solution because the profit equals 0 here. And you don't do anything, profit's equal to 0. And then the objective function here, let's write it down here. The profit equals 80x plus 150 times y. So let's figure this out. The profit equals 80 times 0 plus 150 times 50. Let me see, 5 times 15 is 75, and 2 zeros here. So I make a profit of $7,500 if I do 50 business returns and 0 individual returns. Now let's see if that's a max or not. I don't know, because I have to evaluate the other points into the profit function to see if that's a max or not. So really I'm not quite sure yet. So you have to dig a little deeper here. You have to substitute x, 40 in for x, 30 in for y, and figure out what's going on. So 3,200 here plus 4,500 here, and that looks like 7,700. Ooh, look at that. Now that right there is a better solution because 7,700 is bigger than 7,500. So it's better to prepare 40 individual returns than 30 business returns. I can already see that in the business model. But is that the best? I don't know. So let's take x and substitute 80 for x and 0 for y. So 80 times 80 plus 150 times 0, that's 6,400. That's not good enough either. So it looks like here's my max, right? And it occurs at point B, which represents 40 individual returns and 30 business returns. So what I need to do, my best solution is this. We need to prepare 40 individual returns and 30 business returns to maximize the profit here. Maximize profit, we'll spell it out here. Profit, which is going to be equal to $7,700. So we'll make $7,700 if we, or if she, prepares 40 individual returns and 30 business returns. No other solution, no other combination of the two types of returns will produce as much money as this combination right here. So this is my optimal solution, my best solution here to the problem. And that's example number 2. You just have to try it, get used to it. Remember, doing it with me is one thing, doing it on your own is another. So you need to practice here and repeat these problems until you can do them on your own just as well as me. All right? So do a good job, make yourself proud, go through the problem again, make sure you understand it fully, and then try number 3. And I'll see you in example number 3.